Hi guys, today we're going to talk about linear functions. And one of the things to remember about linear functions is that it makes a straight line. Okay, so linear functions means when we graph it, it's going to be a straight line. So there's different ways to look at linear functions. You can have a set of points. So we can have points that could describe a linear function. We could have a table. We could have a graph. We could have an equation. And we could have words or a paragraph that describes something that is a linear function. And a linear function means it's going to have the same rate of change all along the way. It has a constant rate of change. If we're talking about the equation, it can be written as y equals mx plus b. That's our slope-intercept form of the equation, where m is the slope and b is the y-intercept, and we'll talk more about that. So we're going to talk about each one of these and how it relates to a linear function. So we're going to start with points. So I have 2 points here that we're gonna talk about all the different aspects. So we have 4, 0, and we have 6, 3. So if I look at those 2 points, I want you to think about any 2 points obviously is gonna make a straight line, okay? So I have those 2 points, but I wanna be able to find out the important parts about that line, which is the slope and the y-intercept. So in this case, there's a couple things you can do. One, we're going to graph it. So we're going to take the first point, and remember that the first number is x and the second number is y. So I start at the point of origin, 0, 0, and the x goes over to 4, and it goes up 0. So I'm going to just plot that point there. And then the next one is 6, so I go over to 6 and up to 3. And that would be my line, okay? And see if I can make a straight line here for you. I get the ruler out, so it should be better. Okay. So now I have a straight line, and it will go on and on indefinitely. Okay. So that's if I just gave you 2 points. Now, if we want to put this in a table, this is what the table would look like. I'm going to put the points down here because I want to add some values in between. And we're going to look at what pattern is actually happening. So I'm going to change this color. I don't like that color. I'm going to change the thickness a little bit. And we're going to see what's happening with the x's. Notice the x's are increasing by 2 and the y's are increasing by 3. So since that's the pattern, we can find our slope because slope is rise over run. And when we do rise over run, it's our change in y's over our change in x's. Okay, so rise y's, so it's 3 over 2. So I know my slope is 3 over 2. I'm going to write that over here on the board. The slope is 3 over 2. Okay, that means that it's going to have that constant pattern. And if you look at the graph, notice that if I go from this point to this point, I rose 3 and I went over 2. So you can see the slope emerge there as well. If I follow the pattern backwards in the table, so I'm moving in the opposite direction. So instead of adding 2, I'm going to subtract 2. If I subtract 2, I get to 2. And again, on the y side, I'm adding 3. So if I go backwards, I subtract 3, and 0 minus 3 is negative 3. And I'll follow it back again. So instead of adding 2, I'm going to subtract 2, and I'll end up with x equals 0. And on the other side, instead of adding 3, I'm going to subtract 3, which would bring this to negative 6. Now, that's an important feature here because our y-intercept is when x equals 0. It's the y value. So in this case, I know it should cross over the y-axis at negative 6. And so looking at my line, I've done something wrong. So let's take a look. It should be down 3 and over 2, down 3 and over 2. So my line is slightly off, so you have to be careful about what line you do. All right? And now I'm going to connect these points again. And I follow the pattern all through the table, and that makes a big difference if you follow the pattern all through the table. Okay, don't make those same mistakes like I make. And that's what the line should look like. So a little difference makes a big difference when you're picking out the y-intercept on the graph. So the y-intercept is negative 6. So now if I wanted to write now I know the y-intercept equals negative 6, and you can see it's where I cross the y-axis, or it's where x equals 0. And now I can make it into slope-intercept form of the equation, which means y equals mx plus b, and all I do is plug in the slope and the y-intercept. So in this case, the slope is 3 over 2, and I put that with the independent variable, which is x. And the y-intercept, again, is negative 6, so I'm just going to write minus 6. And that's the equation form. So we have the table, we have the points, we have the equation, and I'm just going to talk about a word problem here. So let's say I have $500 in the bank, and I want to save $25 each week. So I have 500. I'm sorry, I have $500 in the bank, and I save $25 each week. All right, in a word problem, when you're looking at this, your starting point, in this case, your starting point is 500. I have $500. That's your y-intercept. Your y-intercept is 500. Okay, how much your unit rate or how much you do each, every, per, right? Of that is your slope. So in this case, it's $25 each week. That's my slope. $25 each, every, per week, right? So every week that goes by, you add another $25. So repeated addition is going to be multiplication. So now when I write the equation of the line, right, it's y equals mx plus b. And I'm going to plug in the y-intercept at 500, right? So I'm going to plug that in here. And so now I have y equals, I have plus 500 here. I know the slope is $25 right here. And so I'm going to plot that, I'm going to plug that in next to the x. So now next to the x, I have 25. And that's the equation of the line. So we have the equation, we have the word problem, okay? Let's look at the graph. So this graph is not great here. I'm going to just change these. Instead of saying 5 here, I'm going to change these to 500, 400, 300, 200, 100. Okay. And so we're going to start at 500. We're going to start at 500. That's our first point because it's our y-intercept. So we put a point on our y-intercept. Our slope, it's going up by $25 each week. Okay. So each week that goes up, it goes up $25. It should look like this, right? In 4 weeks, it goes up an actual 100 and so on. And so it should look like this. And our line would look like this. Now, let's talk about what makes sense here. Does it make sense that we have negative money when we have $500 and we're only saving? It does not. So this would be actually just a one quadrant. It's just going to go from 500 and up, even though that's not real life and we do spend our money, right? And sometimes we have negative balances in our bank accounts, which is sad. But the truth is, the goal is to start at 500 and only be moving in a positive direction because we continue to make $25 into our account each week. Okay. Now, if you wanted points, we could make a table, right? And we could plug in values for X. So I always like to plug in 0, 1, and 2 because they're the easiest numbers to work with. And I just plug them into this equation right here that we've come up with. So I would plug in 0. 25 times 0 plus 500. And when you plug that in, 25 times 0 is just 0, and you're left with 500. So that is a point, okay? I could plug in 1, equals 25 times 1 plus 500. 25 times 1 is 25, plus 500 is 525, and it should look like this. And if I plugged in 2, it would be 550, and so on. And you can notice the x's are increasing by 1, the y's are increasing by 25. And you can see how this linear function, how the graph, the equation, the words, and the table, how they all work together. They're all telling the same story. And those are representations of linear functions.